All right. Thank you very much, Mr. Speaker. Now, the resolution before the House today is that this House supports the development of artificially engineered bacteria. And on our side of the House, we think this is a really good idea. In fact, so good of an idea that we're going to broaden this. We support the development of artificially engineered bacteria and also plants and also animals, fungi as well. In fact, the one thing, or the only limitation that we're going to put on this is that we don't support the development of artificially engineered human beings. So what precisely is our model here? What we want to say is that in Canada, we will remove all restrictions on artificially engineered animals that are based on their existence as genetically modified or non-genetically modified, or whatever technique is being used. We want to eliminate all technique-related limitations of any sort on the creation of any sort of artificially engineered organism. The only restrictions that we'll place on these organisms are solely based on an expert evaluation of the danger that they might cause. So, for example, if you're breeding together a lion and an antelope to create a liantelope, that's going to be dangerous regardless of how you do it. And we're going to restrict that, but we aren't going to restrict it because it's been genetically engineered.
Sir, but isn't the viability of this stuff to get out going to affect the fact that the government, once they've made the decision to allow this, cannot in the future change their mind and restrict it?
Oh, I'm sure that's going to be your extension at some point, so I don't want to address it too much. But the whole Jurassic Park things are going to escape point, we think. First of all, if you're dealing with risky things, just like we have limitations on what you can do with Ebola, even though it's not an artificially engineered organism, we would place restrictions on what you can do with things that would be dangerous if they got out. But secondly, most things that would be dangerous if they got out, or most organisms that we'd like to engineer aren't things that would be dangerous if they got out. The example being something like all the crop modifications that we see out of the biotech companies generally are designed to make them have more or yield more and not drop their seeds, things that are actually bad for them in the wild, sir.
But won't they then just dominate as long as you're not using chemical energies then to destroy ecosystems when they get in?
No. Like, you just missed what I finished saying in the last sentence before you stood up. What I said was all the modifications that we do make them very good crops, but good crops are not good wild seeds. Like, the reason that a lot of our crops don't look like anything in the wild is because they've been engineered over the course of thousands of years of selective breeding to not drop their seeds so that we can eat those seeds later. When you put that out into the wild, it doesn't do very well because then it's not spreading its seeds and it's not growing anywhere. All right. So that was our model and some argumentation against what they clearly want to talk about. Now I'm going to move into our own argumentation now that I finished my clash. 3 major points. First, talking about why we want new strains of organism and why we think that we should encourage the development of new strains of organism. Secondly, talking about genetic modification and why we don't believe that it's any worse than the alternatives. And then the third point is going to be the benefits of gaining knowledge, both pragmatic and philosophical. All right, so why do we want new strains of organism? Well, what we can see is that over the course of the entirety of human history, since we developed agriculture, humanity has been breeding organisms, largely plants, also animals, etc., to gain advantages for itself. So we've been breeding plants to have higher yield rates, better growth speeds, being able to grow more food in a smaller area. This we see as being inherently valuable. When we can take advantage of the natural world, it leads us to be able to make a better use of the resources we have while having less of an impact on everything else. We can see that there are all sorts of uses that we've made for bacteria, both in terms of the current things we do with them, making beer, that's a pretty important one, and other things like that, but also future uses. For example, there's a lot of research into using bacteria to produce biofuels. There's a lot of research into using bacteria as a way to build very, very small things with nanotechnology. We see that some of the things that we've already done with genetic engineering are things like golden rice, where we've taken rice and put a gene into it that will make it develop more vitamin A, and therefore, we send it out to third world countries, and then they're able to grow this and avoid going blind due to vitamin A deficiency. So we see that there are all sorts of benefits that we can have from changing organisms to do what we want, and when we have more control over them by artificially engineering them through whatever technique, then we can only do more and more and better things with them. We think that's a pretty big deal. All right, so the second point that I want to talk about is genetic modification, why we think that it's controlled, effective, and safe. And to do this, I want to talk about the alternatives to genetic modification. Because if you go back to before GM techniques were developed, the way that they would create new cultivars for plants, for farmers to grow seeds, is they would take a whole bunch of seeds, I'm not making this up, and they would irradiate them. And then they'd have a bunch of mutated seeds, and they'd plant them, and then they'd see what would happen. This was their way of finding new varieties. And so what we can see is that this, when we don't allow the targeted, careful techniques, then we end up with people using other techniques that are more dangerous, that don't have the same level of control, because we don't have, with genetic engineering, you take one small segment of genetic material, you insert it, and then you test it heavily. With this, or without it, we see that other techniques can be much worse. All right, and the third thing that I want to talk about is the benefits of gaining knowledge. So the first of all, there's a pragmatic benefit in that it develops tools for the future. So when we gain knowledge about how to do these things, it enables us first to take more advantage of the benefits that I talked about in my first point, but then to apply these techniques to other things. Because one of the major reasons that we don't want to experiment on humans right now is because it's extremely dangerous and we have no idea what kind of repercussions it would have on these poor children who might be born, and that we think that that would be immoral to create children as experiments. When we have a better idea of what's going to happen to these children because we've done an extensive amount of genetic modification of other organisms, that means that we can take advantage of the tools and techniques we've had to improve human life, to fight diseases, to make people live longer, and all those. I'm sure you can imagine these things. And finally, we think there's a benefit for gaining knowledge for its own sake. We think that human beings are naturally knowledge-seeking animals. That the idea of having knowledge, developing knowledge, and being able to pass knowledge on to the next generation is one of the things that separates human beings from all other forms of life. Unlike everybody else, we're capable of, or every other organism, we're capable of gaining information and then passing it along and not needing to recreate all of our knowledge base every generation. That's one of our strongest advantages. We think that we need to take advantage of the ability to store knowledge. We think we need to go out and find more knowledge. We think that knowledge is good. We think that we should artificially engineer just about everything we want.